Hello, and welcome to the BIM orientation. You probably clicked here because you've been chosen to be a BIM, or you may just want to learn about the BIM program. In either case, I'm going to go over some of the program details here in the next few minutes. Energy costs money, and in our current fiscal environment, reducing costs helps to bring the deficit down and to balance the budget. We are, after all, taxpayers, and the electricity bill here at Camp Butler is paid by our taxes. On the screen here are a couple regulations that you can look up to find out why the BIM program exists. I'm not going to go into that now, but over the next few minutes I'm going to tell you what you need to know in order to do your job as a BIM. BIMs are the eyes and ears of the command, so the information you provide them will help them make decisions on where to spend money in order to make your facilities better. The three areas that BIMs focus on are air conditioning, which is huge because it's about 2/3 of the electric bill here at Camp Butler, lighting, and saving water. Also, you will need to pass a written test in order to become a BIM. The outline for the training is there on the screen there. Samples of the checklist, the BIM checklist, and the trouble tickets can be downloaded from the same Facebook where you found this presentation. So, what does a BIM do? You'll be assigned a building or several buildings depending on what your command decides, and they can range from anything from a barracks to a warehouse to office buildings. But your goal will be the same. You're looking for energy wasters, and that consists of people and equipment. Since the biggest energy waster out there, or energy user out there, is ACs, we'll start there. What you see on the screen is some parts of an AC. You have the intake louvers, and then you have the exhaust fans. And these work together to keep the building cool. As a BIM, one of your responsibilities will be to walk the perimeter of your facilities to make sure that both of these pieces of equipment are clear of debris, grass clippings, and so forth, so that the air conditioning can breathe. Otherwise, the air conditioning has to work harder and use more energy to try to pull in air through all the obstacles that are in the parts that you see on the screen here. Also, the next thing you need to do is make sure that your building is not drafty. Turning on the AC with windows open, doors propped open, that kind of stuff is the quickest way to pretty much guarantee that you're going to waste energy and have a higher electric bill. So you want to make sure that all the windows and doors on your facility are closed. And you also want to make sure that the windows lock. That means the actual lock latch works. This helps to seal the gap between the two window panes. If you have broken latches, which I hear is a common problem out there, fill out a service ticket and get maintenance out there in order to repair. Also, quick note on diffusers. These are the things in the ceiling where the cool air comes out. Do not have people sticking stuff in the diffusers in your building. That does not help at all. It actually wastes energy and makes the building more uncomfortable. The air conditioning is made to work a certain way, and when people put stuff in the diffusers, that just prevents the whole point of the air conditioning distributing the air through the building. So if you have a problem there, feel free to contact maintenance so they can come out and make some adjustments on your particular facility. Next on the list of energy users is the lights. If the sun is shining and the floodlights on the perimeter of your building are on, you have what they call day burners. These are lights that are on when they don't have to be. Day burners can be in areas where there's already plenty of sunlight, like lobbies or some offices. So if you look down in the lower left-hand corner there, you see an atrium, and this might be any building. It could be the Ocean Breeze, let's say. And you got plenty of lights there, plenty of windows there. So you got, if it's sunny outside, you got plenty of light for people to see. If you have a bunch of lights in the ceiling and the lights on the ceiling are on and the sun is shining, you're wasting energy. You don't really need those lights on. So if that's your building, that's your responsibility. Get those lights off whenever it's sunny outside and you don't need them. And the same strategy can be used for office buildings where people are sitting by the windows and all the lights are on the ceiling. You don't need that. The sunlight is good enough to see by, and get those lights off on the ceiling. Nobody's in the room. Do you really need the lights on? Make sure that those lights are off if the room is empty. Just a little bit more on lights. Some of this is common sense, but dirt blocks light. So you have your ceiling fixtures and you have a layer of dust. Thing hasn't been cleaned in 4 or 5 years. Yeah, you're not going to get as much light out of that light fixture. So you want to go ahead and make sure that you kind of keep those clean so that the light that is made makes it down to the people so they can see. And I also want to emphasize again, it's much cheaper to use a lamp on the desk than to turn on all the ceiling lights. So if you can encourage people, hey, use your desk lamp, and let's keep these ceiling lights off unless you absolutely need them. Of course, if it's a foggy day or something, yeah. But under normal circumstances, let's keep these ceiling lights off. And it also helps keep the building cooler. Most ceiling lights are 4-foot linear fluorescents. There's some pictures shown here, pretty common stuff. But I want to point out that they're not all the same. T12s, that's the one at the top there, that's 1.25 inches in diameter, consume more energy and should not be in use anywhere on Okinawa at Camp Butler. If you come across these, let the energy section know so we can write up a project to get those light fixtures swapped out and get some more energy efficient T8s, which are 1 inch in diameter, swapped in. Finally, there's some obvious stuff here. I mean, I'm not going to go into too much detail on it. Turn stuff off when you're not using it. People are in a room, they want to turn off the lights, they don't see the switch, they're not going to waste too much time figuring out where the switch is, they'll just leave the lights on. So as a BIM, if that's your facility, make sure all the switches are marked. We have stickers and switch plates here that emphasize where the switches are, so feel free to come by the energy section here and pick up a few. Also, make sure that you have sleep modes activated on all your office equipment, monitors and printers and so forth. Screensavers look great. If you're going out to lunch, or you know people are going out to lunch, encourage them, turn off your monitors. You're not going to need it for the next hour, so save energy. And that's also close to one of the peak times when our energy prices are the highest. So that's a small thing that we can do that can save a lot of energy and money. Finally, just a short bit here on saving water. If you see water leaking, that's usually a bad sign. That's a waste of water. Make sure your facility has low flow sinks and shower heads if you're given a barracks, for example. These are in the early 90s there was a law passed where the maximum amount of water that can come out of a shower head or sink was 2.5 gallons per minute. For a toilet and a urinal, it's 1.6 gallons per minute. And these are mandated by law, but some facilities haven't been updated since then. So if you're given one of these facilities with the older plumbing equipment in there, let's get it out of there. The energy team can help you write up a project to get that swapped out. Also, make sure that the equipment, if you're in a barracks, let's say, is Energy Star. This is a logo indicating that it's been rated as by the energy department as using less energy. Finally, on the service ticket, this basically lets maintenance know that something is broken or needs to be worked on. I've been mentioning, fill out the service tickets all throughout the presentation. Here you have a sample for one. Not going to go into too much detail about it, but contract number you won't have to worry about. Data request is when you're putting this in. Next thing you have to worry about is your name as the requester, your contact information. You want to be ASAP when you want the service done, and what time. Camp information, your facility number that you're responsible for as the BIM. The shops that you need out there to work on it. If it's lighting, electrical. If it's air conditioning, HVAC. If it's plumbing, plumbing. And then a detailed description of what you saw. The more detailed, the better. And then you can submit it to an email address that's there at the bottom of the sample service ticket. So, and again, this can be downloaded from the Facebook page where you found this presentation. Finally, the energy section is here to help provide you with support. If you want to check and see if your facility is overlit, you feel like, wow, it's too many lights in here. It's probably because it is. Some of the facilities have been designed and they were designed with too many lights in there for the purpose of the facility, or sometimes the purpose of the facility changes. So we have light meters here that can measure how much light is actually in a room, and then we have specifications that tells you how much light should be in a room, and there might be an opportunity to save some energy there and get some of those lights out of there. Is your facility too high? This is a common complaint. Well, you got to prove it. We have infrared thermometer here that you can use to measure the temperature of your facility or rooms within your facility. The problems with mold. We have a hygrometer here that can measure the humidity, and based on the temperature and humidity, we can figure out if you have conditions for mold in your facility. So these are all your responsibility, and we have the tools here, and we'll provide you with the tools and the know-how to follow up on all these issues. Also, finally, when I was talking about the linear fluorescent ballast, there are two different types of ballast. There are magnetic ballast and electronic ballast. There's still a few magnetic ballasts floating around out there, and we want to get rid of those. So we have a tool to measure that. All of this can be found in building 363, room 329. That's where we're located. Come by, stop and chat, and we can show you the tools that we have and how to use them. So, any questions before you have to take your online test?